The following presentation is based on one of the over 600 idea sheets created by teachers for RAFT, Resource Area for Teaching. RAFT idea sheets are a free resource for teachers and available at any RAFT location. They're also available online at raftsac.org. RAFT idea sheets reference various content and grade level standards and are all aligned to address California content standards ranging from grades pre-K through 12. Standards in your state may vary, but RAFT lessons are easily adaptable and often applicable to additional subject areas and grade levels. If you've downloaded the RAFT idea sheet online, you'll find your sheet includes the following sections to guide you through the activity. Topics. Materials list. This activity can be used to teach. Assembly. To do and notice. The content behind the activity. And web resources. Terms in this activity. Measurement. The act or process of measuring to determine dimension, quantity, or capacity. Angles. The figure formed by two lines diverging from a common point. Inclinometer. An instrument used to measure an angle of inclination or elevation. Vertical. Standing upright or at right angles to a flat surface or the Earth's horizon. Horizontal. Standing parallel or in the same plane as a flat surface or the Earth's horizon. Similar triangles. Triangles are similar if they have the same shape and angles even though they are different sizes. Tangent angle. In trigonometry, in a right triangle, the tangent of the angle will equal the length of the opposite side divided by the adjacent side. This video is divided into multiple sections: an overview, what you're watching now, the actual demonstration of the lesson, including a complete materials list, and taking it further, showing some real-life applications for the concepts presented.
Scientists use tools to perform lots of experiments. We use tools to make measurements and record data to help us understand. Through the use of careful measurement, we can reveal what we see and how things change over time. With a tool like this microscope, we can measure things much too small to see with our eyes. And with a telescope, we can measure things that are too far away. I'm Dave Traversy, and today we are going to build and study a RAFT kit called Dangle Angle, an inclinometer for measuring unreachable heights and more. Let's build. To build your inclinometer, you'll need a variety of materials: a ruler, scissors, 3 paper clips, a straw, a CD jewel case, tape, and I've already cut out a paper angle scale that comes from a pattern in the kit. We'll start with tying a piece of thread to the paper clip. I've already taken care of that, and you can look at your RAFT idea sheet to see the exact lengths. We'll need a length of tape, and we'll want to lay the thread down on the tape so that the thread hangs down about 3 centimeters. Take that piece of tape and apply it to the center of the straw. Roll the tape around and be sure that the thread dangles freely. Now this next part is kind of tricky, so we're going to open up the CD case and we're going to place the straw under the D tab and slide it through so that it pops out the side. Go ahead and push it a little past halfway because you're going to want to put the other end of the straw through the opposing D-shaped tab. Then pull it back so that the string is right in the center. Next, we'll take our pre-cut angle pattern and we'll slide it under the straw. It's going to be a tight fit, so you really have to work it in there. Once it's in place though, it'll hold real well. And then we'll adjust the straw so that the string hangs straight down over the 0 angle. Next, close up the jewel case, and I'll set this aside for a second and go to the paper clips. We're going to need to bend each paper clip at a 90-degree angle. Take the larger end and slide that into the end of the straw. Do that on both sides. And these will be used to help you sight your inclinometer. The only thing left to do is make adjustments on the eyepieces so you can sight through them. It seems to be working just fine. Now comes the fun part, taking it outside and measuring the height of an unknown object. I think the easiest thing to start with would be a flagpole that might be located on your campus. You're going to need to have your teacher take you out to the flagpole and position you at a distance from the flagpole that is known. Let's say you're standing 50 feet from the flagpole. What you would do is hold your inclinometer up, point it towards the flagpole, sight through the sight, and then, if you can, have a friend or a partner read what angle. If you don't have a partner, you can just tilt your head over and read that it's hanging right at 30 degrees. Now you know the 2 bits of information you need. You know the angle and the distance from the flagpole. With those 2 numbers, you can calculate the height of the flagpole. Back in the classroom, you can use one of 2 methods to get that information. The idea of similar triangles can be used to get the exact height, or in advanced math classes, you can use basic trigonometry to get the tangent of the angle multiplied by the distance from the flagpole. A little tip for the teacher. You're going to need to know how far your students are standing away from the flagpole. So, ideally, you'd have a very big tape measure. But if you don't have that, you can also use a length of rope that you've taken the time to measure at 5-foot intervals. You could tie one end of the rope to the flagpole, stretch it out, and then have students standing at the 10-foot mark and the 15-foot mark and so on. So they'll know where they're standing and you won't waste any time measuring them out. Devices like this have been around for thousands of years, used for things like surveying and navigation at sea. And remember, there are lots of ideas on your Raft idea sheet for you to think about and discuss with your classmates.